Hi everyone, welcome back. Today I'm going to be talking about function. So I think we're on section 16 now. Okay, so now I'm going to give a bunch of definitions. Okay, so here's our first definition. So just defining what a function is. So function f from x to y, where x and y are both sets. Okay, so that's important. So x and y are both sets. So f can be thought of as a rule of assignment. Okay, so such that for every element in our first set here, our x, there's f sends that each of those elements to an element in our set y. Okay, so another way you could think of this is as a map or something like that. So it turns out that these sets actually have their own definitions. So x is called the domain. Ooh, so something I forgot to really emphasize is that it's a unique element in our set y. Okay, and so I'll go over that again later. But another thing I wanted to talk about is when you do this exists unique, you can also do exist and an exclamation point. So almost like you're taking the factorial of the exists. I mean, that's not actually what it's saying, but it's saying there exists a unique y in the set y. Okay, so that's the same thing as there exists unique. I think the exclamation point is just because just showing existence is one thing, but showing there exists something in its unique is another thing. Like that's a whole nother level, okay? So you could say, well, there exists something, okay? But to show that something is the only thing, now that's one extra layer of information you'd have to give. Okay, so X is called the domain. So it's not like sets that are called X are always called the domain. It's just the first set, the set that F is coming out of, and then Y is called codomain. Okay, so X is where we're taking elements from, and then Y is where we're going to. Okay, so oftentimes how I like to demonstrate this with drawing is I'll draw like two little, maybe they're like a rucksack or something. And so this one is the set X and this is the set Y. So maybe you have a couple of points in here and 2 points over there or something. So F is going to define where all of these elements go in Y. Okay, and we will continue to talk about this and what you are allowed to do, what you're not allowed to do in a minute, but this is the picture that you can have in your head, at least for right now. Okay, so you might be thinking, well, Danica, what if all of them went to that point in this picture, so this element never gets hit? Okay, well, we actually have a way to narrow down the codomain, and we call it the range. So the range of F, so it's specific to F because it depends on what your assignment is. And sorry, I'll write it down and then it'll make more sense. Is so all the elements in Y such that F of X equals Y for some X in our domain. Okay, so basically that just means all the elements that you actually hit, that F actually hits in Y. Okay, so the range is a subset of the codomain. Sometimes it's a strict subset, sometimes they're equal. Okay, all right, so now we're going to move on. I just wanted to state a couple of remarks that are important to remember. So the first one, so a function sends every element in the domain somewhere, right? So it sends it somewhere, but it's not but it can't send it to two places, okay? So the way that I think about it, that I like the visual representation is, say each element in your domain has one bow and arrow with a string attached to it. Okay, so one arrow, I guess, with the bow. So they shoot it over and they hit one element, but that's their only arrow that they have. Okay, they only have one place that they can go if f is a function. Okay, so I hope that helps, that visualization. So a function sends every element in the domain to one element in codomain. Fabulous. Okay, so 2, a function can't hit something outside of the codomain. It's basically what I'm saying here. So I touched on this a second ago, but 2 elements in X can hit the same element in Y. So what I mean by that is domain and codomain. Sorry. Yeah, I know I don't always use the best English, but it's kind of getting to the point. So, okay. So this may be a little bit confusing because you know that an element in the domain can't hit 2 elements in the codomain, but that's where that arrow analogy I think helps a lot. So each element in the domain is given exactly 1 arrow, okay? And it has to shoot that arrow somewhere, right? So it has to shoot that arrow somewhere, and it only gets that 1 arrow. You don't get to bring your own arrow or something. So they shoot their arrow, they only get 1, and the string goes, they hold on to the other end of the string or something, probably get rug burn. And then, but you and the person next to you might have hit the same element in the codomain. But that's fine. That doesn't break any of the rules of the 1 arrow rule. Okay? And that might also help because everywhere where you do hit is the range. And so if you've ever seen, like I always think of Robin Hood with this, where you shoot arrows on a range, okay? And you hit like the little targets and stuff. So if you're hit by one of these arrows, if one of the elements in the domain goes to that element in the codomain, then that element in the codomain is in the range. Okay, so that's why I like the arrow analogy, is because it really does follow through. Okay. So my last remark, an element in codomain may not be hit by an element in the domain. So it all depends. So like I said, the range could be a strict subset of the codomain, or it might be equal. It's going to depend. And so it doesn't always just depend on the assignment rule that the function has, but it could also depend on what the codomain is with that assignment rule. So it really is important. I really want to emphasize that when you're defining a function, it's not enough to just define what the rule is. You also have to specify what's the domain and what's the codomain, okay? Because those could really screw stuff up, okay? All right, so let me draw some pictures. So this is just kind of like some fun visuals. So X, Y, and we'll keep using F. Okay, so F is how we're going to define these maps. So let's start with, I don't know, X having 3 elements and Y having also 3 elements. I don't know. They might even be the same set. We don't know, okay? I'm just kind of making this up. So I am allowed to each element only gets 1 arrow, right? So I can start with that. And now I just need to finish where I land them. So I could just do it like this. Boom, boom, boom. Okay, and that's perfectly fine. So here's an example where the range equals the codomain. But maybe I don't want to do it like that. Maybe I want this one to go here, this one also go there, and this one to go here. Okay, so now the range is a strict subset of the codomain. And this is still legal. This could still be a function. This is a function. Okay. We could even have all of them going to the same element. Okay, so these are all fine. Okay, but it doesn't, you're not allowed to send 2 out of the same, or you're not allowed to just leave one and say, it just doesn't go anywhere. It doesn't like leaving the house, you know, but no, everyone has to go somewhere. Okay? See, once again, it's such a force of habit to check in with how the class is doing, but I have no way of doing that, at least not right now, not this second. Okay, so now we're going to talk about a couple examples, and then you'll try some on your own. So, is this a function? I hope that this is confusing. Well, that's the wrong way to say it, but you can't possibly know because you don't know what the domain and the codomain are. So now it might be a fun exercise. Maybe fun's a little too strong of a word, but think about to make this a function, what could be your domain and codomain? And what could you make your domain and codomain that would make this not a function? Okay, so maybe pause this, jot down some ideas. So here's what I'm thinking. So maybe I'll say function. Okay, so I'll say function. We could have f go from the reals to the reals, right? Because you just negate a real number, you're still a real number. Okay. You could call it the integers, where the negative of each integer is still an integer. Because, for example, not function could be the naturals to the naturals. Okay? Or the integers to the naturals. Because what breaks here? Well, you send 1 to -1, but that's not in the naturals. See what gets my drift? Or here's 0. Where does 0 go to? It doesn't have anywhere to go. Okay? But something that could be true using the naturals is you could use the naturals in the domain and then integers in the codomain. Or naturals in the domain and then the reals in the codomain. That's fine too. Okay, because remember, we don't have to hit every single element over there. We just need to land in the codomain. Okay? All right. Hope this is making some sense. All right. Example 2. So f goes from reals to reals. So now this is a more fair question of me to ask, is if this is a function. Because now I'm giving you the domain, codomain, and the assignment rule. Before, me asking if that was a function was kind of a trick question. Okay, because you can't know until you know what the domain and the codomain is. It was just supposed to be demonstrating. Okay, so that one, and then let's also look at g from r plus. So that's like that's the interval 0 to infinity, but not including 0. Sometimes I might accidentally write the plus up top. It's probably just not the end of the world, but I'll try to remember to keep it at the bottom. Okay. Are either of these functions? Are both functions? Are neither of them functions? What do we got here? So they are both functions. And even though they're the same formula, they're different functions. Okay, and let that sink in for a little bit. Why they're different functions is because they have different domains. So they can't be the same function because, like, f of 0, let's say, for example, is going to be 0. But g of 0, that's not even defined. That's not in their domain. I hope this is starting to make some sense. Let me do some writing. Okay, so I just wrote out kind of what I was saying before. And as I was writing, the devil advocate that lives in the back of my brain said, well, okay, what might confuse them is their ranges are different. Even if I union this with 0, so now the whole thing would be including 0 to infinity, the interval. They're still different functions, even though now they have the same range. So they have the same range, they have the same codomain, but just because they have different domains, then they can't be the same. I hope that makes sense because, remember, every single element in the domain has to go somewhere. So it can't just, so F can't just leave the negatives alone. It has to send them somewhere. I'm hoping that makes sense. Okay, so now I want you to pause the video. Please just try this on your own. Tell me if they're functions or not. And then maybe think about why something isn't a function or why it is. Okay? Spoiler alert, about to go over the answers. Let's use a fun color. I think it'll be October once you're watching these videos, so I'm going to use orange. Spooky season. Okay. So f goes from x to y. F of x equals a. F of y equals b. Yeah. All right. So g goes from x to y. G of x equals a. G of y equals a. That's fine. So they both go to the same place, but g sends it somewhere that's in y. And it sends every element of x. Okay, h of x goes from x to y. H of x equals a. H of y equals b. H of x equals c. Well, since I'm writing it in a set, I'm assuming that a and c are different. Okay, or else we wouldn't give you a question like that where it's like, oh, secretly a and c are equal, but we're asking if this is a function. So okay. So this would be a no, and that's because h sends x two different places, so that's a problem. Okay, so p goes from y to x. Okay, so now y is our domain and x is our codomain. P of a equals x, p of b equals x, p of c equals y. That's fine. Yeah, sounds good. Q, y goes to x. Q of a equals a. What? A is not an x. I thought I was tricky. That is a no.